Great. Hi, everyone. Thank you for joining us on Inner Join, the show where we dive deep into the world of data governance and data management. I'm your host, Shinji Kim, the founder of SelectStar. SelectStar is a modern data discovery and governance platform providing an automated data catalog, lineage, and documentation for enterprises. So today, I'm very excited to explore Apache Iceberg and different table formats with Victoria Bukta. Please comment and add anything on the chat if you have any questions for us. And without further ado, Vicky, welcome to Inner Join.
Yeah, thanks for having me.
Really excited to have you here. I know we met a few years ago in Warsaw, out of any places. Even though we are both Canadian, we met and have mutual connections in Canada. The place that we met was in Poland, and I remember how you mentioned it was your first time giving a talk uh, at a conference. Like your talk was like just full standing room. Everybody's super excited about Iceberg, and I think that was like the time period when I first learned about Iceberg, to be honest. So yeah, I would love to have you introduce yourself of how you got here, how you got into data and into this world of data infrastructure, and yeah, got into Iceberg, Tabular, and now at Databricks.
So I think it's really funny about how I got into data engineering. So I went to the University of Toronto, and I remember being a student and kind of like you're going through school and you're like, okay, so there's like front end engineers that make things pretty beautiful and usable. There are back end engineers who are worried about like server side stuff and databases. And I had like no concept as a student, like what are all the other like types of engineering, production engineering or like data engineering. And I had done an internship, and my mentor from that internship went to Shopify and referred me. So I went through their like referral new grad program, and I went through all the interviews, and I I had the final interview, and he asked me this was like the director at the time was asking me, so like, why do you want to become a data engineer? And I'm thinking to myself, is that the position I'm interviewing for? Like, I have absolutely like no idea. And I'm like, well, at the time I was studying AI, machine learning, and operating systems. I was very interested in operating systems because it was an area of my education where all the theory that I was learning became applicable to real life situations, so like memory allocation and like data retrieval. So I got like a lot of validation out of the theory that I had to learn. I got to see it applied, and that was like really validating for me. So I was like, okay, so data, maybe it's similar. And I gave my response, and then I kind of just landed in data engineering at Shopify. And at Shopify, I was on the data ingestion team. So we were focused on bringing data into the platform to become usable. And that's where I learned about columnar formats like Parquet and why they're valuable and how people query data and all of that sort of stuff. And I did that for a number of years and kind of reached a tipping point within Shopify where one, the performance of our data wasn't great on very large data sets. So how can we increase that performance? And number two, the management of this data was becoming unwieldy. At the time, this was like back in 2017, we as a company at Shopify we had our own data centers, and we were just moving to the cloud. Like it kind of feels weird, like talking about like on-prem and this cloud migration, but back then that's what we were doing. And we had our Hadoop cluster, HDFS with files, bringing that to GCS. We were like a Google Cloud Platform shop, and we had all these files. And it's like, what files are part of a table? How do I manage access controls of this table? How can I make this data more performant? It was just, we needed a solution around that. So that's how I kind of got involved with Apache Iceberg and table formats about like, how do we actually manage these huge data sets at scale?
That's amazing. Just to step back a little bit, when you say growing amount of data and the data ingestion, Just for our audience, can you clarify what types of data you're talking about when there is of large volumes of data that needs to be ingested in a stable manner, or more in like a high throughput, low latency type of environment? Like why this part was hard to scale, or why this part, what aspect of that data was required when you are thinking about ingestion perspective?
Right. So a large part of our data ingestion was data from Kafka.
Mhm.
So this was all event data. So say someone is on a website and they're clicking around. So all of these like clickstream data were going into systems like Kafka. Maybe that data was getting used for other purposes, but we also wanted to archive it for long-term future analytics. And when we talk about volume of data, we were talking about like maybe ingesting like 10, 15 petabytes a day. Like we have to get this like into our data lake and make it queryable. Not that to say all of that was equally important. We went through large initiatives to try to like quantify like what is the SLOs across these data sets, because different ones had different importance. But for some of the data sets, we had SLOs that had to be like under an hour. So we had an hour to get data from our Kafka topics to make them queryable. So large volumes of data, low latency. I know maybe an hour doesn't seem like a lot of time. An hour was like kind of like the upper limit, but really we were writing to these data sets. Like when we were talking about Apache Iceberg, like every 5 minutes we were committing new updates to the table.
Wow. And why was it so important for some of these data sets to be available for analytical purposes quickly?
So I think it had to do a lot with anything that was customer facing. Shopify was interesting because we had our own internal analytics, which was important, but we also offered analytics to our merchants. So merchants, they have you have an online store, you have people making purchases on your online store. Maybe like you want to see how customers are interacting with your store. And we had different kinds of merchants. We had everyone from like, small mom and pop shop to like Kylie Cosmetics. So like, you have a flash sale, you want to understand how your large organization, your store, how's the sale performing? So people want those analytics immediately. You want to see like what is the time to conversion of the sale, how many sales are being fulfilled, if there's any problems, how many leads are coming in through various platforms like Instagram or Facebook. So
Yep.
these are all analytics that we provided to our merchants, and that they want real-time feedback.
Of
So one
course.
of the things that was very like when you go through the support, you try to understand support in big organizations like that are customer facing. Like merchants would say, I saw someone make a sale on my platform, but I don't see it in my dashboard. So we were trying to
Mhm.
close that gap of, you see something in one system, your operational system, I want to see it reflected in my analytics immediately. So we were trying really hard to close that time gap.
Yep.
So that's what was the huge driving factor around like near real time. I don't want to say real time because we're not talking about milliseconds, we're talking about minutes, but near real time analytics and making them available.
Totally. Yep. So I guess going back to the ingestion pipeline, Kafka was able to queue all the messages. Now it's about making sure that events are safely and securely written into a format, database, a table, so that the dashboards can run on top of it, or reports can be generated, right?
Yeah.
So yeah, tell me about that. Like this is, I guess, what was that flow like at Shopify before, and how did you end up moving that into Iceberg?
So we had we had an old system that was running on Apache Spark. And what we used, we had this batch system. We had these jobs, these Spark jobs that would get launched every, let's say, hour. So again, because we're launching the job every hour, all of a sudden we have an hour of latency. So we had these batch
Very
jobs
bad.
that would, we'd have these batch jobs that would run every hour. They would look at offsets that we were storing about where we had read from Kafka last time. It would read basically an hour's worth of data, write it to a folder in GCS as Parquet files, and then the job would shut down. And then it would spin up again an hour later. So we had this like batch job for all our Kafka topics. And to close the gap, I guess you could say, why don't you run it continuously, right? Like, why don't you have like Spark streaming and writing these files as Parquet down to something like GCS? You could do this like every 5 minutes and get like your latency down. You can, but then you run into all sorts of data management issues. So the nice thing about, for us, pulling the data every hour was because we got to write larger Parquet files. So, and with larger Parquet files, we got better query performance. If we brought our time all the way down to say like, maybe we ingested every 5 minutes, the size of our Parquet files were really, really small. So small, maybe they only have like 100 rows in them or less. And all of a sudden, the performance, the query performance of these tables would dramatically increase. Like the time it would take to run a query would dramatically increase. So this is what we call like the small file problem. There's too many files to access. This is a lot of network calls. Each file you have to open up. It doesn't contain a lot of data. So the round trip of the whole network call is becoming an issue. So you want to increase the size of these files. So this had to do with how we were storing the data on disk. And you would say, okay, why don't you go back and like rewrite a bunch of those files, like make them bigger. Like, yeah, ingest in 5 minutes, but consolidate, compact.
Maybe, yeah.
Yeah, like compact these files. And the issue that we were running up against was actually, how do you do that in a safe manner? Because in object stores like S3 and GCS, you don't actually have like atomic operations, like an atomic replace. So it was possible for us to delete those files and put them back. And you would either, if someone was querying at the right moment in time, either like not see those results or see duplicates. Because you would have the old files, the small ones and the large ones. So we had this like data consistency issue. How do we go back and like modify the underlying data? It still represents the same thing, but how do we modify the way it's laid out in a safe way to keep these data sets highly performant? And so we needed some sort of like abstraction on top of just files in an object store. And that's where table formats like Delta, Hoodie, and Apache Iceberg come in to provide some sort of extra layer on top. So we can do maintenance on the data under the hood.
Wonderful. So just, I guess, for our audience, you've started at Shopify as a software engineer in the data ingestion team, and have basically gone through this adoption of Iceberg as you were scaling the systems. And this is how you ended up also later in Tabular as a principal product manager. Is that right?
So senior product manager. But yeah, so when I left Shopify, I was actually managing the data ingestion team. And Tabular folks reached out and they said, like, you've been involved in the Iceberg community. I had done a lot of talks, like the one that you saw in Warsaw, about Apache Iceberg and the work that we were doing on our ingestion team with Apache Iceberg, the challenges we faced, but also how we solved those problems. And they said, hey, you're really knowledgeable, and we need someone to help us figure out what to build moving forward, like what would be useful tools. And the thing about the data engineering space is you need the context from being on the ground of like, what are the problems these engineers are facing and what are common problems, like not just within my team, but like in general that are applicable. And these are problems that like everyone will face. So I had a lot of that context of how to manage these data sets at scale and the problems that you run into. So I think they saw me as like a great candidate. And we knew each other from the community syncs. Like I used to attend, like, I think it's like every 3 weeks, they have an Iceberg community sync. So me and my team used to attend. So they knew me from that like ecosystem. So they reached out and it was a great fit.
Yeah, that's awesome. And I think a lot of like when you can really dissect these technical aspects that you're facing in the engineering side, be able to communicate that with the rest of the community and other people inside and outside the company. This is like something that also for you to be able to synthesize what would be like the next steps and improvements that can be made for the project or for anyone that might also want to cater or adopt that type of technology. So I guess to go back to where you are now, you're looking at table formats, how to make these files to be able to be updated on more near real time, but then have it so that the query engines can actually read it so that it's coming from a consistent larger file. What were the options that you were considering at the time, and what made you to make this decision on adopting Iceberg?
Right. So this all comes down to data management. So like, how do you manage? I kind of like alluded to this, like we have all these small files, and that's just the nature of real time or near real time ingestion, is you're going to have to publish all these small files to make them available to be queried. But that's not the ideal state. The ideal state, like I mentioned, is you have these larger files, like maybe we're talking 500 megabyte like size files. So you want a mechanism to go back and safely, in the Iceberg world, we call this compacting. Delta has something very similar. I forget what their name is, but like basically you go back and you optimize the table afterwards for performance. So the nice thing about Apache Iceberg and Delta is basically what they are is a metadata, like a set of metadata protocols about how we store information about the data that's stored in the table. So in Iceberg, the way this would work is I would have a series of Avro files that have the location of my Parquet file along with all the metadata about the file. So this metadata is actually coming from the header of the Parquet file. So you get information like what is the min-max values of this column, like that are contained in the file. So all of that information gets put into these metadata files. So when the query engine is ready to read, it goes to these files and just sees like, here's the whole list. Here's the whole list of the data that's actually part of my table. So if I write other files in that location, the query engine isn't going to know about them because I'm telling you exactly the whole path to the data file itself that it needs to read. So what that allows me to do when it comes to data compaction is I can see the data that's stored in the table. I can see the sizes. Part of the metadata that we store is also around the size of these files. I can see the whole list of files. I can see how big they are. I can identify which ones are too small. So I have some sort of threshold, like maybe my threshold is like 500 megabytes. So I get the list of all the files that are under 500 megabytes in size, and I can rewrite them. And then I rewrite the metadata. And then finally, I do a commit. So when you use something like, when you use Apache Iceberg, what you're doing is you have to work together with a catalog. And the catalog is backed by some sort of database. This could be like MySQL. It could be Hive Metastore. It could be like, there's other like catalogs in the market, like Unity Catalog and Polaris by Snowflake. So what these catalogs do is they will actually perform the commit, the actual update to the database. And because the commit to the table is handled by the database, that's the thing that gives us atomic transactions. So there's no risk of me writing all this stuff in the object store and this data that's like not ready to be read will be read by an engine. We don't have to worry about that because no one's going to read it until this one little piece of metadata is actually finally updated in the database. So it's basically like updating a pointer in like a file system. So it's just like a series of pointers.
And the database side is, would you say that's provided by the catalog, or is it coming from like a different layer?
So the database is coming from the catalog. And this database could be, so this database could be like Hive, it could be like a MySQL database, it could be something else.
Whatever that supports the Iceberg format.
Exactly.
For example. Yeah.
Yeah.
And so I guess what are those catalogs that are available today? And do they all support, would you say, like the same amount of capabilities? And was like Tabular's product also basically that catalog database type of functionality, would you say?
Yeah, so maybe I can spend a little bit of time to give context of what Tabular was actually offering as a product. So what Tabular was doing is we called ourselves like a headless data lake. And the reason for that was like we didn't actually offer any compute services. Like you couldn't like run a query like on the Tabular platform. What we offered was the catalog. So just to like showcase like how valuable that component of the ecosystem is, we offered a managed catalog. And what this catalog would do is everything I said, but also handle the whole life cycle and management of your data as well. And that could be like this compaction operation that I mentioned, optimizing the table under the hood so it's query performant, things like access controls of your data. All of this can be handled by the catalog. So Tabular offered a catalog that worked with Iceberg data sets. Snowflake has announced Polaris, which is supposed to also work with Iceberg data sets. But at Databricks, we've announced Unity Catalog, which we open sourced at Data in AI Summit about a month ago. And I think like what's unique about Unity Catalog that we're working on here at Databricks is actually when you look at a company's organization, like we talked about Shopify for a little bit and how I had all this streaming data coming in. But actually that was just like a subsection of all the different kinds of data assets that we had at our company. We have maybe data coming in through CSVs. Like maybe you have like Excel spreadsheets. You have sales team, you have surveys that you run, you have all these other kinds of data sets that you have to integrate with your system and make available and provide governance on them. So this goes beyond like Delta and Iceberg. And what Unity Catalog is trying to do is actually be like the catalog to govern and manage any data set. So whether it's Iceberg, whether it's Delta, Hoodie, or it could just be your CSVs, right? A bunch of old CSV files, or maybe a collection of one-off Parquet files in a folder. Like I want to make this available to my organization, but I also need to like control who has access to it. So that's what Unity Catalog is trying to do, but that's also like what these catalogs in general do. It's about governance, it's about management of the data sets.
Yeah, well, I think earlier when we talked about Iceberg and the database side of the catalog, this was initially starting from more of to support the query engine, right? So that there is an atomic transaction and also there is the management of the files. So you're saying that tools like Unity Catalog is also for managing the access of the different tables and columns. Would you say that is true for other Iceberg catalogs too? And that happens through the metadata layer that Iceberg formats provide?
So this governance layer around like access controls is not something that's supported by every catalog. So when we talk about the Iceberg ecosystem, at minimum, what the catalog must do is that performance of the commit. Like that is its primary job. But in reality, in your organization, you need the catalog ideally to do more. You want the catalog to provide access controls. You want the catalog to provide integration to your different query engines. So whether that's Apache Spark, whether that's Trino, or maybe like other engines you want to run at your organization. It is like the narrow waist. It is the intersection of the data and everything else and access to your organization.
Yeah, it almost feels like the application part of the database, right? It does not necessarily hold the files, but does all the management and the interactions to the data directly. So that's where I guess like that's why this access side also comes into play.
Yeah. So what we did at Tabular was our product offering of the Tabular catalog was everything. Everything meaning, you can perform your commits like with your Iceberg clients. You can govern these data sets, who has access to them. So you can register like all the users in your organization. You can specify user groups, grant those user groups different permissions. Maybe there's some columns they can't access. Maybe there's some data sets certain people can't access or update. Like maybe you don't want anyone to be able to access, maybe you don't want anyone to be able to write to your data sets. You want all the writing to be taken care of by machines. So this was very common at Shopify, where we didn't want people to have accidentally like update and like delete rows or modify rows in a table. We want to make sure that any modification to data is run by infrastructure and was version controlled. So these are different ways that you might want to like control access to your data within your organization. And that's what we did at Tabular, was focus a lot on the governance piece, but there's also the lifecycle piece of your data. So when we talk about Delta and Iceberg, like when we talk about large analytical data sets, this is gigabytes, terabytes, petabytes of data in a single table, right? So you have the optimization piece. These formats also allow for time travel. And when we talk about time travel, being able to query what the data set looked like maybe last month, last year, now we talk about governance in the context of GDPR and privacy legislation. And maybe in your organization, you need to make sure data doesn't live past a certain point in time. Like maybe private data that's marked as like sensitive, needs to be purged from your system within 30 days. So these are all things that a managed catalog can provide you, these services, to be able to identify what's sensitive, identify when something should be purged, and maybe even do the purge for you.
Right. Makes sense. So I guess just in terms of like completing the picture of database perspective, there is the last bit of part, which is the querying side, right? Querying the database side on the analytical side. There are Spark jobs that you can run, or there are queries that you can run. What are the usual suspects of the ones that accesses Iceberg catalogs that you see in the market today, and how are they different from one another?
So I think this is not going to be a surprise, but the biggest engine that table formats today have to support, including Apache Iceberg, is Spark. Like Spark is a major player in the database, in the query engine space. And so that's number one. These catalogs need to support integration with Apache Spark.
And can you delve a little bit more into where Spark is currently being utilized mostly today? Would you say it's primarily, because like the parts that when I think of Spark is either machine learning, or it's like a large ETL, like, what used to be like MR jobs, but now we are just running it on Spark.
Yeah, so you're right on. It's these machine learning jobs. It's like these ETL jobs. Spark is used to do a lot of the heavy lifting when we have to distribute compute, not necessarily quick retrieval of data. That's a separate
Right.
problem. You maybe want to use something like ClickHouse for that. But when we talk about, I have a large job, I need to scan a lot of data and maybe need to modify a lot of data. So we're doing this large transformation job. This is where Spark is really, really useful.
For sure. What about for then ad hoc querying, analysts that are trying to come up with the analysis or putting together dashboards? Do you see that type of workload also happening a lot on top of this, I guess, the architecture of, I guess, Lakehouse or Iceberg catalog on top of Iceberg catalogs?
So I think this is an emerging space, and there's a lot of like room for improvement. I think where we are heading with the Lakehouse architecture is trying to merge having a single place to store data to serve both these like ad hoc queries and reporting workloads, as well as what we just talked about, like these heavy transformation jobs. So I don't have to duplicate data. So when we talk about those reports and jobs, the query engines that come to mind for me are maybe something like Trino, something like ClickHouse. I know DuckDB, a lot of people are starting to use that for very specific smaller workloads. But all of those engines I just mentioned can support Delta and can support Iceberg. So the catalog and the Lakehouse kind of architecture becomes the single points of truth. So because we can have a catalog that understand that like ClickHouse can understand, Trino can understand, and Apache Spark can understand, what I've done is it's become the single point of truth, and I don't have to copy all my data into something like into separate places. So I can have one copy of the data. I don't have to like have data in like my object store and then copy it into something like BigQuery or Redshift and maintain multiple copies for different kinds of use cases.
Right. Yeah, that makes sense. Then would you say like tools like Athena is a good use case here too, to run ad hoc queries and reporting? And do you also see any like workloads of, let's say, dbt transformation queries running on top of Iceberg? Was that things that you've seen customers implementing?
So actually at Shopify, we were becoming a dbt shop, kind of like while I was there in the last few years. So we did a lot of dbt. So I see Iceberg and dbt working really well together. dbt, for like those who may not be familiar, it's a way to describe your like data modeling using like Python, Jinja templating. So it's almost like its own query language or modeling language in and of itself, and has its own kind of practices and principles, like philosophy. That's not my like area of expertise, but there's no reason why something like dbt can't be used with Spark. And so you can use Spark and dbt together, and because that works well together, Spark has access to your Iceberg data sets. It can all work together.
Right. Yep. Yeah. So whether it's Spark or SQL or Python, something that actually basically retrieves, transforms, and makes changes to data, or I don't even know what to call it. If I should call it a database, right? Because like the catalog, like the top catalog that you're talking about, is really more like a database. It's beyond just next level information schema. It actually because it's not just about tracking the changes. It actually makes the changes to the files or data. So I think with that, I'm curious, like, to hear a little bit more about the differences between these table formats, Delta, Iceberg, and Hoodie, and what the vision is with the recent acquisition, how Delta and Iceberg is going to be either merged or what's going to happen. If you can share a little bit more about the upcoming roadmap.
So I can't speak to specifics, but like I have like, and I can't speak to Hoodie that much. I don't know too much about the Hoodie ecosystem because I'm not that involved with it. But in terms of Tabular and Iceberg and Databricks and Delta, what was announced at Data and AI Summit was that the intention is we don't want people to have to worry about what table format they're using, right? So Delta and Iceberg are solving similar problems in slightly different ways, but at the end of the day, they're an abstraction on top of files in an object store. Like at its most primitive, like that's what both of these formats are trying to do, to offer a variety of benefits that we discussed like over the last like 30 minutes. So with this acquisition, I think the intention is to show that there is an opportunity here where we can provide a platform at Databricks where people don't have to worry about format and they can get back to writing SQL, which at the end of the day, you don't want to be worrying about your infrastructure. Infrastructure becomes a distraction. What you want to do as a company is to build models off your data to drive like business insights, right? That's your market differentiator as a company, is your data and the insights that you can pull out of it. Your market differentiator is not because you use Iceberg, not because you use Delta, not because like, you know what I mean? It's about gaining insights out of the data that you do have. Like that's your oil, like equivalent, like data is the new oil. This data is very, very valuable. So we want companies to not have to worry about the management of their data, don't have to worry about how it's stored. That's our expertise here at Databricks. We want you to get back to writing SQL and modeling.
Yep. So I think this is now more of like let the Iceberg catalog manage everything, and like in the cases of Databricks, that's Unity. How do you, so I guess like going back to just overall Iceberg, because there's been a lot of like almost like a really meteoric rise of Iceberg in the market. Maybe like, you know, as someone who's been part of that ecosystem for a long time, if you can comment on the aspect of how other companies have been adopting Iceberg and the aspect that they've been seeing, the use cases that you found that were a truly differentiated and making positive ROI of their infrastructure. Any infrastructure change always also takes a big amount of investment. So
yeah, so any sort of migration from old Hive ecosystems with Parquet files to something like Delta or Iceberg, that's a heavy lift. And we experienced that at Shopify during my time there. Like it's a lot of work. It's a Band-Aid that I think most companies will have to pull off at some point. And you can either make it go really fast and it's going to be hard, or you can stretch it out over a long period of time, but it's just going to be painful for like a year, 2 years, however long you want this migration to take. So the journey is hard, but I think the payoff in performance and also the management capabilities, the governance capabilities, that gets unlocked and becomes much simpler after you do one of these migrations. You asked about organizations. I mean, I can't talk about like other companies, but I can talk about a little bit like through my own experience. Basically, what I saw with the migration to something like Iceberg is not just the query performance increases, but the simplicity of governance. So we saw this a lot like at Tabular with customers like adopting the Tabular platform, where they could just have a single place where they can manage access controls. And I know like access controls is not like the most beautiful thing, interesting thing to talk about, like IAM permissions and all of this, but whoever, like anyone who's had to work directly with AWS, IAM permissions, or like Google Groups and GCP, it's really hard. It's really hard to understand like all the different permissions you have to give. It's really easy to screw up. And all of a sudden, like, I'm making some modifications to these groups to like close down access. And then all of a sudden pipelines break and having to figure all of that out. It's when we think about access controls at the granularity of a file, like most people can't think about that. And what I've seen in practice by organizations is they often grant too much access because it's just easier. If I give everyone read and write access, then everything works. Things start to break when you start closing down access, and that's not great, right? So that transition about how do I lock down my organization, because it's difficult, people kind of like opt to keeping it
I think
too open.
there are two levels of like kind of sophistication. One is like when it's down to the file or kind of like parts of the file. How do you like make sure that the access is being done? But for that part, let's just leave it to the catalog.
Yeah, and
catalog figured out. That's a technical, mechanical part. Now, regarding just overall data access perspective, what are there anything in particular that you would say that makes it easier to grant and manage access when you have your data formats in Iceberg?
So the fact that I could just refer to stuff by a table name and not a directory or a collection of directories, I think makes a huge difference.
Okay.
Right? Because that's what happens when you use something like Delta and Iceberg is like, now I can refer to this table as my production quarterly sales instead of, my data bucket, blah, 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 blah. This kind of quarter.
Handles that part, right?
Yeah.
Okay. I'm also curious because like usually for us like at SelectStar we deal with a lot of like at the level of us with SelectStar interacting with other catalogs or other databases. So getting or granting access level of the tables is more of kind of like the norm of where we would start from. But like I was curious whether like because when you trace queries or the usage, if there are because there are a lot of different aspects of the access that can be applied for like tracing whether this table or this specific column was derived from a different column that might be more sensitive, so that when you are granting a table, like it's not just the whole table, like you're already aware of some of the sensitive information that might have been transferred from.
Yeah, so I think this is, again, you're demonstrating the power of the catalog, like having this other abstraction on top. And the fact that like your catalog and other catalogs can determine what columns are sensitive and then tracing that information through. One of the things that we did at Tabular is actually having your access logs, like audit logs of who is accessing the table, what files are they accessing, what is the query that they might be running on the platform. So understanding all of that gives you the ability to do this tracing, but also auditing to make sure like, are my permissions too open, or like who made some change? Like we have all these audit logs.
Mm-hmm. And right now, the query log perspective, is that something that you see other Iceberg catalogs also track today?
I think when it comes to, so actually in the Iceberg community has, I don't know how many people are familiar with this, but there is actually like a REST catalog spec about how you can interact with a catalog. And not all catalogs interact with this spec, but this is kind of like a standardization that's slowly being pushed by the Iceberg community. And one of the endpoints that a catalog can implement here is actually a metrics endpoint, where you can ask for data and it will spit out metrics about like It's like an exchange between the query engine and the catalog to say, what am I querying? How am I querying it? And this becomes really powerful. Actually, one of the things that we did at Tabular was get all the queries people were running. So that gave us insights to how people were querying the data so that we could then later optimize. Like, oh, it looks like you're querying by this column. Like this column ends up being very important. If we clustered or partitioned on that column, you would get better query performance. So there's actually a lot of insights as a data platform that we can get from understanding how people are using the data.
Yeah. And I think that's really a key for kind of like a lot of these next generation data catalogs to be able to understand and at least keep track of the queries and the activities that are happening for sure. So I guess now at Databricks, you mentioned that you're starting to get involved more into the open source Unity catalog project. Can you tell us a little bit more about that? I understand that this was, I think, a fairly big announcement. Unity catalog, from my understanding in the past for Databricks, has been more of making all the technical catalogs that used to be distributed between multiple Hive meta stores into one, so that Databricks, when I'm managing data in Databricks, it is much easier. So what does that even mean? If I am now, I can do my own hosting of Unity catalog, and how would I use that compared to, I guess, what has already been done and is hosted on Databricks?
I think, yeah, so I'm working on a bit of the release of the open source Unity catalog work. So there's going to be a big release and announcement the end of August. So I suggest people follow the Unity catalog project to see what kind of updates are coming. But more broadly, why would you want to do this rather than the managed catalog? I think managed Databricks Unity catalog offers lots of features. Features around the data compaction, the optimization of these data sets, the governance of these data sets. So we talked about access controls, identity. All of that is baked into a managed product. Now, when we talk about the open source product, what are some things that are different? So some of the things that are different are around those workloads that are being scheduled in the background around compacting, optimizing your data sets. That takes actually a lot of compute and is not something that's orchestrated by the catalog. But the catalog is the source of truth for data sets. So that remains true. I think what the purpose of open sourcing this catalog, the purpose is a number of things. But number one is a stepping stone and migration path to the Databricks ecosystem. A big struggle for organizations is I need to be able to set this up internally before I integrate with a third-party vendor, right? So we talk about, I have a lot of experience in the Hive ecosystem. And I worked with GCP a lot, and GCP has their own managed hosted Hive metastore. But I needed to have some sort of reference within my organization to make sure everything I'm setting up is going to work. So I had my own hosted Hive metastore. I have a Hive metastore that I can use in testing environments so that I know when I deploy, everything will work as expected. So I see the open source Unity catalog, at least at the beginning, to be this implementation that I can use as a stepping stone to Databricks. If I can get it to work with open source Unity catalog, I know one-to-one, it will work exactly the same, but with managed services within Databricks.
Got it. But I would so for someone who is, I guess, considering, but not necessarily why would I want to try out or adopt a open source Unity catalog if I am not necessarily looking into migrating to Databricks?
So you can always use these open source products. Like, Apache Hive Metastore is also open source.
Yeah, so I could use Hive Metastore, or it's to, so I can host it myself.
You can always host infrastructure yourselves, but from what I've seen is people don't want to be distracted by having to host and manage infrastructure. Most
Right.
people want to defer that work to some sort of vendor, like whether that is like Azure, AWS, Google, Databricks, some other organization. That's a lot of work just to host that, and people just want to be able to query data. I think by open sourcing Unity Catalog, what we're telling the world is this is how, if you want to interact with us, this is how to do it. And here's an example. Like, it's an example playground, and all the features that we offer, like I shouldn't say features, all the integrations that we offer with the open source are the integrations you're going to get with Databricks. And I think what's unique about Unity Catalog is that most of the time when we talk about Hive, when we talk about like Polaris, we're talking about like one table format. Like we've talked about Iceberg today, but I really want to like broaden this to think about all the different kinds of data sets that your organization might have. You may have Delta, you may have Iceberg, maybe you're using them for different use cases. Maybe you have CSV files, maybe you have PDFs in your organization that you also want to like control access to. Actually, with Unity Catalog, you can govern all those assets under one roof. So we have this concept of volumes so that you can manage access to arbitrary files or folders. We can manage native Spark types like CSVs and Parquet. And then it understands as well like Iceberg and Delta and Hoodie. So it becomes one place to govern everything rather than something like Polaris, which has been marketed just to support Iceberg.
Got it. So it's really focused on both tabular type of data as well as unstructured data and others.
Yeah.
That's the goal here. Got it. Okay. That makes sense. Cool. So are there any upcoming features or enhancements to Iceberg that you're excited about that you can share with the audience?
I think the most exciting thing, and of course it's exciting to me because I'm working on it, which is Unity Catalog, but Iceberg support within Unity Catalog and Unity Catalog support with Apache Spark. So I think that's going to be a really exciting release that we're going to have at the end of August to look out for.
Okay. What about for the community side? Are there, who do you see as like the active players in the Iceberg community today?
Oh, that's a great question. So I think it's still some of the bigger historic Iceberg shops. So it's going to be Netflix, it's going to be Apple. Who else would be there? Like Cloudera, Dremio for sure. So, and I think if you want to get more involved and you want to see the community, attending the Iceberg community syncs that I think happen every 3 weeks is a great way, as well as the Iceberg Slack channel. So all of that, if you go to the Iceberg website, you can see all the information about like how to get involved there.
All right, exciting. Well, I think I learned a lot. This was a lot of fun. So thanks so much for your time today, Victoria. Great catching up with you and also learning more about Iceberg, what's upcoming with Unity Catalog. I think it's a very exciting time in the industry, how we are starting to see more of this convergence of data in some sense. Yeah, I'm curious like whether like your also belief is that the data just needs to stay all in one place. But like I think this is like what a lot of companies are thinking, because I also see this like aspect of what people call zero ETL as a movement. What's your opinion on that?
I think I'm a little bit too far away from the zero ETL movement. Like just like in terms of like where I work and where my headspace is at. But I think there's a lot of work to get to the ideal state. And I think today there's still a lot of organizations that haven't even adapted a catalog, haven't even adapted some sort of table format, whether that's Iceberg, Delta, or Hoodie. And I think we're on this migration path right now from just historic Hadoop land still to adoption of a table format and a catalog. And this is just going to unlock a lot of future possibilities like zero ETL.
Got it. And the folks that are, I guess, the organizations that have not migrated to catalog, they are just using Metastore. Is that right? Like the Parquet files and Hive Metastores?
Or maybe they don't even use Hive. Maybe they just have full, like files in an object store. Maybe they're still running HDFS Hadoop with files there. So I've seen all of the above.
Amazing. Yeah. So long ways to go, but it's great to see companies like Tabular and Databricks and others that are charging the path forward, especially with the community involvement of Iceberg. I think seeing all of these larger companies adopting to new formats, I think has been really remarkable to watch. So, but
Absolutely.
Thanks so much for your time today. Great chatting with you, and yeah, have a great weekend.
Yeah, you too. Thanks for having me.
Thank you.